Welcome to lesson 6 of the Unreal Engine 5 horror game tutorial series. In this lesson, we'll learn how to create interactive door that open and close realistically. A key feature for building tension and atmosphere in any horror game. We'll use the interaction system from the previous lesson and add the smooth door movement with smart position based logic. In this lesson, you will learn how to prepare static mesh by adding and refilling collision hulls, implement the smooth time-based animation using timeline, and create advanced functional where door automatically swing open away from the player using the dot product calculation. Let's begin by preparing our door asset and setting up the basic simple door blueprint. I'm gonna use Unreal 5 starter content door. The domains are available in the starter content under groups folder. You can find do and do frame. I am drag do frame and do into the level. Now if you hit play, and you will notice you can work through the SM door. This is because it lacks a collision hull. Without collision, our line trace can't detect it. So fix it. Double click and open SM door. Navigate to collision tab and select this add box simplified collision. This generates a simple green box shape representing the physical boundary of the door. Notice the generated collision box is extended out to include the doorknobs. Since we only need simple block collision for the door slab, we can't shrink it slightly. In the details panel, search collision. Go to primitives, expand these boxes, and this extend set to 5. This pull the collision box back slightly, prevent unnecessary collision volume around the door knobs. Now save this. The door is now physically ready, and close this. Now you hit the play and walk through the door. You can't work through the door. Now go to content, go to blueprint, and go to actor folder, and create new folder called create a new folder called interaction. And this BPI interaction actor, move to this interaction folder and open it. Now right click on your BPI interaction for blueprint and select this create child blueprint class and name it to BP door. Then open BP door blueprint. Go to the component tab and select cube. In the details panel, change its static mesh to SM door frame. In the materials, use the yellow reset arrow next to the material to ensure it use the default door frame material. In the component tab, add component and select static mesh and name it to door mesh. And make sure is child of the root component, this cube. And I'm going to compile and save and minimize this and open VPI interaction actor and rename this cube to static mesh. And compile, save, and go to BP door. Now click door mesh. Go to details. In the static mesh, select our SM door. Due to the mesh pivot point, it will be offset. Select the door mesh and go to details. Under transform, select Y location to 45. This properly center the door slab within the frame. Now go to the event graph. In the My Blueprint tab under interface, select this interact and right click and click implement event. Now drag this exit print and search timeline and select this add timeline, and I name it to open door timeline. Then click this, double click this open door TL and open it. Set the length to 0.5 and click this track and add floor track and name it to alpha. Now right click in the graph and click this, select this, add key to curve float, and again right click and select add key to curve. And now select first keyframe and set time to 0 and value also 0, and select second keyframe and set time to 0.5 and value to 1, and click this zoom to fit horizontal and click again zoom to fit vertical. Now select both keyframe and right click and select this auto. This create motion feel much smooth and less mechanical than a line transition. Now go back to the event graph. Go to component tab and drag this door mesh to graph, and door mesh to add set relative rotation. Set relative rotation and connect this update to this set relative rotation node, and drag this new rotation node and search make rotator and select this make rotator, and add lerp node to this and connect this alpha to this alpha. Now go to viewport and select door and go to the rotate tool and rotate the door and rotate the door and check which way it open. In my case is negative 19, so I go to the event graph and set this B value to negative 19 and I click compile, save. Now add the new variable called is door open, drag into the and graph and get it, and we need a branch node and add, and again drag this is door open variable and click set is open, and connect this to true, and I need another one and connect this to play node and connect this pole to this set and click is door open is enable and connect this to reverse, and click this is door open, connect to the condition and click this door open and go to the compile. Now details panel you can find is door open and enable this, and again compile, save and minimize this. Now let's test it. I'm hit play. Oh, sorry, we need our door frame first. First open view window, go to the viewport and select our door frame and set Z rotation to 0 and compile, save and close this, and I'm delete this door and door frame and drag this view door group into the our world, and I'm hit play and go to the door and I'm click key door, now it's open, and I'm press again E, door is closed. The door is now fully interactive. Opening door, the players from one side and away from the player on the other. Okay, we make our first door, but it only open in one direction. So now let's make a door that opens in both direction. First, go to interaction folder, right click in the BP door and duplicate it and name it to BP outer dots. Now double click and open VP output door. Before we dive in, let's assume VP interaction actor has a basic door setup from a previous lesson, like timeline that rotate the door mesh to open or close. For now, we are keeping timeline that rotates the door on the Z axis, but we need decide it rotate to 19 or negative 19 degrees based on which side the player is on. This is where dot product come in. They help us figure out the player side relative to the door. Okay, to make the door open away from you, we need to know which side of the door the player is on. We'll use a dot product to calculate this. It's a math trick that tell yes if the player is front or behind the door. Let's set up in BB outdoor door. In the event graph, right click and get player f variable. We got player f variable, but it's not show in the variable tab. So to fix it, I minimize this and open our main BPI interaction actor. The BPI interaction, click this button in the my blueprint and click enable show interact variable and compile, save. Now go to BP outdoors door. You can see our variable is now appear. So I am drag this and get player f. Before this, I saw some warning in the BPI interaction actor, our main interaction actor folder. So to fix this, break this link and add this to get controller power node and connect this to this object and compile, save. It's gone burning. This core issue is that we are using class 2 level 1 character node, but the object we are plugging into the player controller. A player controller is an entire separate object from a character. They do not inherit from each other. The engine knows that a brain can never be a body, I mean character, because the conversion is impossible. The cast will always fail, especially in the warning you see. To fix it, we add get controller power to the get player controller. This tells the engine get the controller, then find the body it's possessing, and then check if that body is my level 1 character. This is the correct way to find the player's physical avatar. So it's fixed. Then go back to BP outwards door. So player F node, add a actor location node. Get actor location node. Get player F access the player ref variable, which is our level 1 character set in BP interaction actors event begin play. and again right click and search cell and click this get a reference to cell and add the get at the location node and add this return value to the vector subtract and connect this to return value. This node give a vector from the door to the player showing the direction and distance between them and normalize to the result and add normalize to this one normalize and I bring this to here. Okay, so this normalize turn the vector into a unit vector keeping only the direction. This makes the dot product easier to interpret. So return value drag and search dot and select this dot product. Now go back to self and get forward vector. Oh no, sorry. Drag this self and get forward actor. Get actor forward vector. And plug this return value to the dot. And go back to dot and drag this and click promote variable and I'm it with to the dot product. Then set this set to the this and this connect to player from start and break this reverse line and connect it to the reverse from end. And go back to love and drag this B, search select float node and go to variable and drag dot product to the graph and get it and add the float node, this one create equal and connect this to this pick one and click compile and save and select this select float B value to 19 and A value to -19. Now compile and save and close this and drag our BP output to into the level. Now hit play, approach one side and press E, door open away, press again E to close door and go to the other side and press E, open away again, press E, close to door.